Hello, everyone, and welcome to IFMA's weekly webinar series. We are thrilled to have you with us today. My name is Starlin Chadwick with IFMA, and I'm happy to be joining you from Houston, Texas. Before we dive into today's presentation with Armstrong, we would love to hear from you. Please take a moment to like, share, and comment in the chat to let us know where you're joining from. We love to see it and would like to know where everybody is from. While you're getting settled in and sharing your location, I would like to take this opportunity to introduce everyone to our moderator for today's webinar. Our esteemed past chair of IFMA's Global Board of Directors, Dean Stanberry, will be joining us today. Dean, how are you doing and where are you joining us from?
Well, hello everybody. I live in Denver, Colorado, so I'm joining from my home office in Denver. Thank you all for joining today on today's topic, which is 5 fundamental shifts, healthy buildings and decarbonization. So we have 2 esteemed panelists with us here today. First, I'd like to introduce Dr. Joseph G. Allen. Joe is the associate professor at the Harvard T.H. Chan School of Public Health and directs the Healthy Buildings program. Joe, if you want to join me on stage here, maybe talk a little bit about what else you're doing and how have you come to this topic today?
Yeah, so thanks, Dean. Thanks for the introduction. Thanks to IFMA and Armstrong for inviting me to participate today. I'll open just the short couple remarks on what I'm seeing as real fundamental shifts in terms of the building space. I hope it's useful to the listeners out here because I think we're on the cusp of some of the biggest changes I've seen related to buildings, certainly my 20-year career. So let me just start by talking about the first fundamental shift is the paradigm shift. Kind of funny, actually, this morning to be thinking about, this afternoon to be thinking about fundamental shifts, but I'm going to keep it to buildings and fundamental shifts related to the buildings. The first is there is a rewrite of the scientific and medical literature related to the ability of buildings to protect us from respiratory pathogens. If you went back before the pandemic and asked scientists about how something like influenza is spread, you would find disagreement. Some people think it's from surfaces. Some think it's spread through these large droplets. Some people spread through the air. We won this argument during COVID and demonstrated unequivocally that the dominant mode of transmission for all respiratory pathogens, SARS-CoV-2, influenza, RSV, is through small aerosols that travel beyond 6 feet and accumulate in a room like cigarette smoke. Now, the relevance to you all is that that's a key point and a shift because it means the building matters when it comes to health from respiratory pathogens. And it corrects a 70-year mistake in medical textbooks. The floodgates opened. People in my field could not even get this message through the top journals in the world until the pandemic. And the floodgates opened. We published in all the top medical journals now, and it's now accepted and changing practice in hospitals. That's not going away. That's a fundamental shift. The second shift is a policy shift. The science has changed, but also the willingness of people setting policies to recognize airborne transmission. A quick history lesson, very short. 150 years ago, we used to design and operate our buildings to protect against respiratory pathogens. We did this for 100 years. We had ventilation rates designed for health, but in the 1970s, we started to restrict the airflow in our buildings to save energy, which is good. We'll get back to that. But at the same time, we choked off the air supply so much, we created these sick buildings. That had been the standard practice for about 40 years, but there are big changes happening right now. Number one, there are scientific bodies standing up. The evidence that says the threshold used to be here. Let's set new health-based ventilation targets like we used to have. The CDC in the US set its first ever health-based ventilation target. ASHRAE set a brand new standard. It's first time it has set a health-based ventilation target. That's all changing and changing policy. And as an example of change policy, just over this summer, bipartisan legislation in the US focused on healthy indoor air quality. Going to fund more of EPA work in this area, talking about certifications, new standards. So that's a big policy shift. The third one is that there's an awareness shift happening that's still happening. So of course, people paid attention to buildings towards the back half of the pandemic, but the awareness is still high. So I'm showing 60 Minutes here. So this is a news show that over 10 million Americans watch every year. There was a story on buildings and indoor air quality. Never thought I'd ever see that. New York Times had a 3-article headline news story about the new war on bad air, talking about the new war on bad indoor air. This has now hit mainstream news. The fourth is a technology shift, and I think this is a massive one that probably most people are not prepared for. The proliferation of low-cost indoor air quality sensors means that anyone anywhere can go out and tell you about how your building is performing. Used to be the case, you'd hire a scientist like me, take an expensive piece of scientific instrumentation out there, measure the air, send your report, maybe it gets buried in a desk. Now people are not only measuring it, but they're sharing it in social media. That means if your building is not, there you go, Dean. If your building's not performing well, the world's going to know it and your employees are going to know it. Just this summer, actually, I do a lot of work still on forensic investigations of buildings. I was out there looking at a building and a tenant came up to me. I started asking about indoor air quality. This is a first for me. They said, I've already mapped the entire building. They have a low-cost sensor. They knew everything about the air quality in every space in that building. That's what building owners and managers are up against, is a highly informed and knowledgeable now workers and guests and clients who can measure indoor air quality. Really interesting and important that this is only going to grow. Right now, people can measure a handful of things on these air quality sensors, but the ability to measure specific microbes like SARS-CoV-2 and influenza is coming. ARPA-H, Advanced Research Projects for Health in the US, is funding, to what I hear, about $50 million, a new project to develop and commercialize low-cost sensors that measure the amount of virus in the air. Could you imagine this scenario where people are out measuring carbon dioxide and telling you what the levels are in a building, and in 5 years, having a sensor they can say, hey, there's a lot of influenza in your building. That's going to change everything. The last shift we're going to talk a lot about today, I've written about in Harvard Business Review, is there a question of whether healthy buildings are in conflict with green buildings? I think the answer is unequivocally no. We'll talk about that through the rest of the webinar, but that's the shift. We've had this COVID created a healthy buildings focus shift. Climate is bringing it back to a green building shift, and the big questions are out there is, can we do both? My short answer is, of course we can and must do both. But these are as I see, big shifts that are really changing everything to do with how we design, operate, and maintain our buildings. Thanks, Dean.
Thank you, Joe. Next, we're going to bring on our other panelist, which is Mick Dunn. Mick is a technical sales manager at Armstrong World Industries. He specializes in innovative building materials, including phase change materials, and I hope he tells us a little bit more about that, which are aimed at improving efficiency and in indoor environmental quality. So Mick, why don't you give us a little bit about what you're doing, what Armstrong's doing in this area that's going to help us with this, answering these questions.
Excellent, Dean. Thanks for having me on. Joe, thanks for setting things up as well. So, yeah, my name is Mick, and I'm from Armstrong World Industries. I'm joining in today from New York City, but typically on the East Coast in North Carolina. And yeah, my focus has been a little bit more on the operational carbon side of the sort of decarbonization efforts, but where Armstrong kind of plugs into some of this is in our sort of work with interiors of buildings and ceilings in particular. We have these assets that are in a large volume of buildings, and the question sort of comes up of what can we do with these spaces and buildings using structures like ceiling grid to make use of those assets to do more than just what we normally see designers and building operators select and specify for, which is acoustics and aesthetics, and leveraging and turning these assets into things that can help us with both indoor air quality and with operational carbon savings in the form of this stuff we call phase change material. And so the phase change material side of this is a product we have called TempLock, which is a ceiling tile that has a phase change material technology on the back of it. And phase change material is just like any material that's undergoing a change in phase from a solid to a liquid to a gas. So water is a very good and simple, abundant, natural phase change material that goes from frozen ice to water. And when it does that, it takes a huge amount of thermal energy to achieve that change. And so what it's actually doing is absorbing heat. And so taking that and sort of using that framework, we can sort of see that we could, introduce something like that into a ceiling, imagining a phase change material that can freeze and melt at room temperature. So now we could imagine pre-cooling a building early in the morning with ventilation to help improve indoor air quality, but also to charge a ceiling that can help us absorb heat during the daytime and reduce the amount of energy and peak demands in buildings, especially as we near and trend toward decarbonization. So in addition to that, obviously Armstrong has been really a forerunner into moving into indoor air quality with a suite of different products that can be grid and ceiling integrated to help both filter and treat indoor air contaminants. So pleased to be joining in today, and a good discussion as we jump into these fundamentals.
Thank you, and that's an interesting technology that we're seeing, coming out now. So, Jack, I think you can remove that and just put us all up on the screen here, and we're going to get into our, panel discussion. So we have a few questions that we've kind of posed here. The first one is, how do recent regulatory actions around carbon reduction and electrification impact the balance between creating healthy buildings and reducing carbon footprints? So, Joe, I'm going to toss that over to you first, and then Mick can follow up.
Yeah, I think let's start with the why we're doing all this, right? So buildings consume 40% of global energy. So it's urgent. If we're going to address the climate crisis, we're going to have to do something about our buildings. And across cities, really across the US and across the world, mostly at the city level, there's really strong building performance standards that are requiring owners and building operators to reduce their energy footprint. Makes sense. Let's talk about the other why, around health. So we spend 90% of our time indoors. The indoor environment has a massive impact on our health. So we're going to have healthy building strategies that keep people safe. My personal feeling is that we've taken these two ideas, a green and a healthy building, let's call it, and pretended they've been in conflict for 40 years unnecessarily. Hey, we've had energy savings at the expense of health. In my view, it's unacceptable to have a green building that's energy efficient where people get sick inside. Equally unacceptable to have the super healthy building that ignores a responsibility to the planet. I do think there is a good question about how do you actually do both, and can it be done? I want to give you an example, and it's JP Morgan's new headquarters, 270 Park Avenue, New York City. I've been an advisor to that company and project for a long time. And I think they're showing that you can actually do both, right? So it takes good companies sometimes to show the way. So this is a building that's an all-electric tower, all right? So no fossil fuels burned on premise. They're sourcing it with renewable energy through renewable energy contracts. They're doubling the amount of outdoor air coming in. So while they're being energy efficient, they're also bringing in a lot more outdoor air, using high quality filters to clean that air. And they're using real-time air quality monitors to smartly control the building. And they're actually showing you can do both at the same time, meet your decarbonization goals. This is for a new build in this case, while creating a healthy environment. And we've seen the same thing can be done for existing buildings. We can talk about that a little more in a little bit. So first, with the why, we have to achieve both. And I just think it's been a false premise or a false setup that it's like we choose one or the other. I think some of these healthy building strategies don't have to be energy hogs. Clearly, you can see what Armstrong is doing. And full disclosure, I've been an advisor for Armstrong for many years now. I only work with some really good companies. I think we're aligned on mission and vision. I like what they're doing. They've challenged me to think about, well, how do you think about the ceiling and the building envelope in this climate and healthy building strategy? Well, they're showing that you can actually do some of these really, I think, pretty easy strategies to help address some of your energy load, energy burden, while actually improving indoor air quality at the same time. So there's a whole bunch of strategies that can be used, but I think first and foremost, we've got to start with the why we're doing it, and then recognize that it's not an either or value proposition.
All right. Mick, can you talk about how some of these, technologies, which are, fundamentally passive, like structural, and they can help with the reduction in the actual energy consumption or the operational carbon?
Yeah, sure. And just to kind of touch on that electrification, decarbonization piece, the more that I'm talking to, say, utilities and sort of policymakers and state sort of folks as it relates to grid and like, why are we doing this? Sometimes you sort of sit in these large rooms of people kind of iterating on electrification, and the question seems to come up, well, like, aren't we just burning natural gas down the road so that we can power a building with electric, and it's just really inefficient because we think electric. But I think it's sometimes maybe helpful to also think of it like a car going down the road on highway mileage versus sitting idle in the middle of the city. And so when you've got electric power or natural gas fired, or even worse, coal-fired power plants sitting and idling at 2 a.m, not doing anything with that energy, but they're sitting ready, they're incredibly inefficient. And we've got all these buildings that we can kind of use as a battery, so to speak, if there were ways that we could be leveraging that off-peak power, the cheapest power, the highest efficiency cooling and heating opportunities with excess heat that's available on the grid. Having these buildings connected to the grid gives us that better flexibility to make those power plants run a little more efficient while we figure out how to electrify the grid. But then I think the other aspect of that is obviously the emissions that come from these buildings when they're burning natural gas and things like that. In terms of boilers have emissions, these are things sitting in the basement of buildings. And so that's always a thing that, sort of ties in just like cars do as well in terms of having emissions. So it's something that I think we're certainly sort of seeing in the overall discussion. On the passive side of things, when we kind of return back to that and think about buildings as a battery, we're seeing more and more discussion and exploration into sort of how we can turn buildings into grid assets and use the assets in the building to flexibly have buildings respond to the needs of the grid, so that you could potentially pre-cool a building early in the morning, not just because you're trying to save peak energy on your chiller in terms of the building owner, although that would be something that's going to result from that. But if a grid operator is able to do that and reliably be able to turn your building down in the afternoon, or even do a little extra cooling at noontime during lunch breaks and things like that, there's all of these opportunities as we begin to build out the assets in a building. And there's this kind of trickle down effect that helps with indoor air quality when we sort of look at that overlap of, like, is indoor air quality sort of benefiting from some of those things, and occupants, and then occupant comfort is the other one that really benefits as well, in terms of the more that we use some of these ideas and approaches in terms of ventilation, the more comfortable it is in buildings, especially when it's nice and cool outside, and we can bring that fresh air into a building to support occupants. So a ceiling that can operate as a thermal energy storage or battery that can be used to pre-cool or even be melting and absorbing heat. You think about all these high-rise buildings in Manhattan that are receiving huge amounts of solar gain coming through windows. We can harvest that free heat in the middle of January, store it, and give it back late at night, overnight, as temperatures cool down. So these are all sort of parts of strategies overall in buildings that we can begin to think about. How do we turn buildings into something that's a grid asset, and then something that can improve indoor air quality and comfort for occupants as well?
Well, thanks for that. The U.S. Department of Energy has actually released a couple of papers on grid efficient buildings, or GEB, and talking about that transition from our current utility infrastructure of generation, transmission, and distribution, which in the future becomes more transmission and distribution as the energy sources become more distributed. So those are available through the Department of Energy's website as well. Moving on to our next question. Can you provide some examples of green building practices that also directly benefit occupant health? How can the synergy between healthy buildings and decarbonization be maximized? And I'll toss that back to Joe to start off.
Yeah, I think it's a really good question. I'll let Mick talk about what they're doing on the ceilings and some of the building envelope stuff, but I'll point to a couple of strategies from the Lancet COVID-19 Commission. So during the pandemic, I was the chair of the Lancet COVID-19 Commission's Task Force on Safe Work, Safe School, and Safe Travel. And we put out a report about the first 4 healthy building strategies every building should pursue. And there's a tie-in to green buildings here. Because the first is the simple act of commissioning your building. Right. So a lot of times we have design standards for buildings, not performance-based standards, and building performance slips over time. And commissioning is the process. I just talk, well, this audience knows what it is, but I talk about the public around, giving your building a tune-up and making sure your systems are operating the way they should. Lawrence Berkeley National Labs estimates this not only is, well, from an energy perspective side, you're going to save energy. means you're going to save money. And then all the studies that look at the commissioning benefits, including some of my own, show that you see improvements to indoor air quality. Systems are performing the way they should, and they're performing optimally. You're going to improve indoor air quality, save money, and save energy. Lawrence Berkeley estimates that the payback on some of this ROI is just a couple of years. So simple. That's a simple one, right? No brainer. On the other side, we think about, hey, how do we bring in a bit more ventilation? How do we bring in a bit more outdoor air, but do it in a way that you're not getting an energy penalty? I think there's a couple things we have to do. One is you want to use things like the smart sensors we've been taught, where you showed, for use demand control ventilation. It just doesn't make sense anymore to be bringing in outdoor air conditioning that air, spending all that, taking the energy penalty and the money penalty, and dumping it in everywhere in the building, even when people aren't there. You want the building to scale and respond to occupancy. This is absolutely no-brainer. It's intuitive, makes sense. Also saves money and saves energy while delivering better air quality to the people when and where they actually are in the building. We can do some things from the design perspective around ventilation. We can increase what we call ventilation effectiveness. So it's getting smart about where you're placing things like diffusers. Some underfloor ventilation is a good strategy. You can increase ventilation effectiveness by 10 or 20%, sometimes depending on how you actually design and operate this building. We should and can be using things like energy recovery ventilation, such that as the air that has been heated and cooled and we pass it back out of the building, well, it passes with the incoming airstream, and you're retaining all that energy that you've already spent money on and carbon on cooling down. And actually, some of the systems Mick will talk about actually helps with that already, how the load and the actually amount of heating and cooling you have to do. We can also put in air cleaning technologies. And I mean here like basic filtration, right? I know Armstrong is active in this space too, so are others, but you increase the level of filtration, you can save energy by actually providing high levels of quote unquote clean air, that's highly filtered air, without taking that energy penalty. Some of these filters are really have a low pressure drop and come with marginal, if any, real energy penalty. So just a handful of ideas that are really just on the ventilation air quality side, not even talking about building envelope, not even talking about ceilings, just a couple simple strategies that you can improve ventilation, airflow rates, filtration, building operation performance. You're going to save energy and then also improve overall indoor air quality in the space.
All right. Well, thanks for that. That's definitely something that we see. I think most energy performance consultants will tell you that a simple ASHRAE level 1 audit will generally find between 15 and 25% energy savings for a building that's not gone through regular commissioning or retro commissioning. Mick, you want to take off on that?
Yeah, I was going to add to it. I guess firstly on the air quality side, and it'd be interesting for you to comment on it, Joe, whether we're seeing trends in the direction of maybe carbon monoxide monitoring or carbon dioxide monitoring not necessarily being a proxy for good air quality, that there's more and more technologies coming online that are sort of treating or sort of measuring airborne contaminants so that we can throttle down our ventilation. And so with more intelligence and more sensors and more feedback, we get better at figuring out what to sort of protect for. I think in the past, the assumption has just been if I'm opening the window, so to speak, I'm getting fresh air into the building, or if I'm pumping in 30% outdoor air, that's good and everybody's got good air quality. But we may be able to throttle that down to 10% with the assistance of other technologies that are measuring for what we really want. And then so some of what Armstrong's been doing, I guess, is more ceiling integrated treatments that can be used in classrooms and office environments that utilize air treatment technologies within the ceiling just to help move air across filtration and treatment solutions to help improve air quality inside spaces. Some of those things, along with monitoring systems and things like that, I've started running into more and more in buildings that we sort of interact with that are really trying to move the needle on having a good idea of how to manage ventilation and treatment of air.
Yeah, I can add to that because I think it's a good discussion about what we can measure and then how do you leverage this kind of information to make decisions about which strategy to deploy at what time. And I'll just show a sensor here that let's see, I'll just get my blurring off here, that Dean kind of showed, and I'll show another sensor too. So Dean showed a device like this, been showing it on TV, right? It measures carbon dioxide. I have another sensor here in my office that not only measures CO2, but is actually measuring displays up here, but it's actually measuring particles as well. And that starts to get to your point, Mick, about, we can use these measurement devices to make better decisions about how much ventilation we need at what time, and in response to what's the outdoor air quality like, what's the indoor air quality like. And I think this is a really important discussion for the listeners, because the way we've done energy savings in building largely, when we're trying to adjust operations and operational energy, we've been flying blind to the ramifications to indoor air quality. Right. So if you're a facilities person, maybe you're tasked with saving carbon, saving energy, and we'll make tweaks to our building operations all day long. And we don't always measure the resulting impact to indoor air quality. So that's a problem. One, you might be making what you think are good decisions around energy saving, and you might be creating the conditions which we know have contributed to sick building syndrome. This has been a problem for the past 40 years. I've done these investigations where people have been sick in buildings, sometimes headaches, sometimes not feeling right, sometimes they're out sick, sometimes it's respiratory pathogens, sometimes they've died in buildings. So I've done this for my entire career, because a lot of times we're tweaking buildings without knowing what's actually happening. The promise, I think, of the new air quality sensors is that you can start to take informed decisions. So you want to save energy in your building, you can start to identify, well, where am I building my overventilated? Where am I doing it too much, maybe? And also importantly, maybe where I'm not doing it enough, where health is being compromised. I think there's a danger in trying to make some of these tweaks without understanding what the impacts are on health. And really, it's flying blind. And I've seen this in buildings already that have these air quality sensors deployed, where you start to make really informed decisions, because you can show that if I made a change, I can save energy without compromising the health of the occupants in the building. Without compromising the health of the occupants in the building. That has not been the way it's gone over the past 40 years. And I think the proliferation and the availability of these low-cost sensors is actually a wonderful tool to help us get there. We're probably in a lot of buildings, we're wasting a ton of energy in a lot of buildings in really dumb ways. But a lot of times we're guessing how the impact maybe impacts people's health. And maybe it's just fine if we make some of these changes, save a lot of energy, and we say, hey, the air quality stayed great. Perfect. Then you're in good shape, but you're telling the people in the building, I care about your health, and I'm monitoring that. And if we're changing building operations, we're ensuring we're not doing so in a manner that's going to make people uncomfortable, unsafe, or unhealthy.
Yep.
Yeah, I think it's what you were just talking about, the sensors, and wrapping up that kind of topic in general. I think it makes me think of that there's a lot about like the disease, so to speak, that we just don't know. If you think of it in terms of medicine, if you want to try to create a drug for something, you really need to understand the disease that you're dealing with, or the thing that you're trying to treat. In our case, there's a lot we just don't understand about what goes on in buildings. Some studies that Armstrong often references in our work, especially around energy and ceilings, is that some surveys of 62,000 occupants of buildings, the number one source of dissatisfaction in buildings was acoustics and noise. So, this is an aspect of human health as well. And you can't concentrate for a test. You can't heal because it's too noisy next door. There's too much of an echo. You can't hear what your doctor is telling you or what your teacher is telling you because of those disruptions. These are major problems that we run into. In addition to that, temperature was the number two problem in buildings in terms of problems and complaints, hot and cold complaints. So when we just take those two, let alone the air quality, there's a lot we just don't know about our buildings. It's not like we have sensors everywhere in buildings measuring decibel ratings and sound transmission ratings. But you only have to step into your local restaurant to get a sense of whether you're happy or not, and whether you can hear your friend or your partner talking to you. And so the more that we have that information, the more that we can figure out what to do with it and where the problem areas are within buildings we need to go treat. Same thing for temperature, but we can kind of begin to see where those issues are most likely to show up, both in geography and in high density cities, but then within buildings themselves. We can think about solar facing areas where we're pretty much guaranteed to have more hot and cold spots. So the more of that sort of approach to diagnostics and sensor input, I think the better. I think what's exciting though is that as we sort of move into this generation of AI and sensor input, the ability for us to interpret that data and figure out what to do with it gets better and better and better. So I think, the timing is really great for the directions that we're heading in to make buildings operate more and more efficiently and in a healthier way. So.
Yeah, you said something interesting about, we don't have sensors in all these buildings, but, we have people as sensors, so they can detect things like the acoustics aren't quite right, it's too hot or too cold, something feels off. People generally describe bad as like it's stuffy or stale in here, don't quite know. The air quality monitors are helping us see the things we can't see, particles and CO2 and the like. But people are generally pretty perceptive, as we all know, about the space. And it's interesting because I know, and again, as disclosure here, I advise Armstrong, but I actually think they've addressed with a different set of a product they've been building with that's an air cleaner that actually is quiet. So I think about, all of our struggles during the pandemic. How are we going to clean the air with all these, and people are putting in portable air cleaners. I love it. Great temporary strategy. But you walk into these buildings, they're turned off. What? They're loud. They're noisy. They're disruptive. And I know Armstrong focuses on acoustics, and they have some of these air cleaners that are designed to be very quiet. So it starts to solve that problem. Hey, can you clean the air? That can help save energy and quiet. You're not disrupting what's happening in the classroom or the building. And I think we need a lot more of this. So again, I'm not trying to plug anybody's products here or not, but I just think we need a lot more of this kind of thinking that says, to Mick's point, it's not just the air quality thing, it's not just respiratory pathogens, not just energy. Yeah, it's also acoustics. And the lighting and everything else in the space. And how do you leverage everything, the building envelope, the ceiling, the mechanical system, such that you deliver a high performing space for the occupants? That's thermal comfort, that's acoustical performance, that's lighting and views, biophilic design, air quality, filtration, and while being energy efficient and thinking about our responsibilities to what's happening outside the four walls of the building. So I really like this, we're having this discussion. I think it starts to bring in this big picture of all the ways buildings are influencing our health and how these things are interacting, and also some of the solutions that I think are right at hand to start to address some of these that I don't think are all that expensive, not all that hard to put in, but we just haven't done it, I think, because our policies, quite honestly, and standards haven't had these kind of health and energy goals as the North Star for a very long time. And I see these big shifts happening that's suggesting that, yes, these are back to North Star, and people, probably like people tuning into this, are looking for the solutions. What do we actually do in the buildings? Recognizing we're all trying to hit these goals.
Thanks for that, guys. So one of the things that my observation here, so we've been talking a lot about what are we doing in the buildings we have. I believe the average lifespan of a commercial building in the United States is 53 years. So we're talking about, how do we work with the hand we've been dealt, in a particular building, and make some of these changes. So let's shift the conversation for a second here to talk about, how important are the considerations of building materials when balancing health and decarbonization in the architecture and engineering of constructing or renovating commercial buildings? And Mick, I'll have you start with that one.
Yeah, so I guess there's two major things. The first thing that pops into my mind is what I was touching on earlier, using ceiling grid, and the ceilings is sort of one of the examples of things that we're running into, where we have a lot of buildings that we learn in and heal in and that we work in that have ceiling grid and acoustical ceilings in place already. Those are assets that we can use. And with very little effort, we can introduce thermal energy storage to help support things like decarbonization and more smoother temperature ranges and things like that to make buildings more comfortable and more energy efficient. But ceilings being something that are easily retrofittable, easily accessible. You don't have to demolish the entire building to rebuild your building envelope to make a difference. This is something we can do very seamlessly and easily using, just strategies that are already in place in buildings. So that's an important aspect. And these are solutions that are really designed to integrate into the built environment and design process of new construction and renovation projects to easily add some of these features into buildings as they're getting specified. So leveraging labor and overhead and contractors and distribution that's already in place to improve some of those outcomes in these renovation and new construction projects. I guess the second element of that is the embodied carbon side of the equation. The footprint of the materials that are being specified in buildings obviously have an overall outcome to the outdoors and our decarbonization efforts and low VOCs of materials that are being specified. That's becoming more and more of a trend, especially in certain areas of the country. But we've always been trying to push the needle on those things to make sure that everything we're using, everything we're specifying or encouraging to use has the lowest footprint on the front end, and also in its use case can reduce the amount of energy that as much as possible in the operational side now, but in particular not have a harmful impact on occupants when we're installing these materials that also need to be removed from buildings in the future and disposed of. So that overall life cycle becomes part of the equation that we're seeing a lot more discussion around. But those are the two areas that specifically for Armstrong, ceilings play a big role in that. We have so much one-to-one square footage of ceilings. Every building has a ceiling. You may have a roof, but the roof may be on the 10th story of your building, so it's only having an impact on one story, whereas ceilings are on every floor. Same with floors and walls. So we have this opportunity to really do something and be good stewards about what we can use that asset for. So.
Yeah,
Dean, can I add a health lens on the healthy materials, this materials conversation? Unless you want to go somewhere else.
No, go ahead.
Yeah, because I think this would be helpful for people. Like, I think one of the big places we're seeing movement on the materials side, clearly people are thinking about the embodied carbon that's in these materials that we're using. And I think it's part of this bigger conversation on healthy materials more broadly. So, for example, I'm a faculty chair of what we call the Harvard Healthy Materials Academy, and we're really starting to think about materials we purchase in terms of their embodied carbon and the energy that goes into them, and also about the types of chemicals that are used in these products. And this is a movement that's really starting to grow. And our playbook at Harvard, I think, is really quite simple. One is we demand transparency. So any product we're buying, we're asking, well, what's in it? What's in the materials, right? We have a right to know what we're buying. It seems straightforward. And two, we want to avoid known bad actor classes of toxic chemicals. And we're telling suppliers and supply chain, we don't want any of this stuff in our products. This playbook or a similar playbook is now used by the Googles of the world, Salesforce, and other the major companies. On Harvard's campus, we have 50 pilot projects that now are built with these healthy materials. And to bring it into discussion with Mick and also what's happening in the industry, if you look at, like, for example, the American Institute of Architects, they now have a materials pledge. It has 5 aspects. And I think this is where the field is going. And actually, one of the challenges for 2025 is how do you select products that do it all? And the 5 are this. So this human health is a focus on toxic chemicals. How do you get those out? There's a focus on climate health. So how do you reduce the embodied carbon of these products? But there are other focal areas, social health and equity. How do you purchase from manufacturers that secure human rights in their own operations and supply chains? This is language from AIA. Ecosystem health, regenerative, natural air, water, biological cycles through a thoughtful supply chain manager and restorative company practices. And the 5th one's a circular economy, reusing, improving buildings, designing for resiliency, adaptability, disassembly, reuse. So this conversation about embodied carbon and materials is a bigger one that has carbon and climate in it. It has healthy materials, toxic chemicals, but it has circularity and these other elements. And quite honestly, it's an area to pay attention to over the next couple of years because it feels a little disjointed to me currently. There's a lot to take in. It's not quite obvious all the time. If I'm buying product A, how do I be sure it meets all of these? And if not, which do I prioritize? Climate, health, circularity, which one? But there's movement here that's really important to be paying attention to, outside of the carbon and health conversation. The materials conversation is bigger.
Mm-hmm. Absolutely. I think one of the areas that we first saw environmental product declarations, EPDs, emerge was around concrete. So there's a lot of effort going into trying to reduce the embodied carbon of concrete. And I think the statistic is that if concrete were a country, it would be the 6th largest carbon emitter on the globe.
Yeah, that's right. And I tell you, so the parallel to EPDs, or environmental product declarations, is, for example, when Harvard's buying products for our buildings, we demand HPDs, health product declarations. So you can see where this is going, and it's good. I think some of these third-party certifications are really kind of helping because it's making sense. When you buy a product, you just want to know you're buying a good product, what's in it is disclosed, and it's actually starting to meet all these kind of the full materials pledge framework.
Yeah, certainly it's become, I think, exciting to see that grow. I agree, Joe. It is a confusing landscape for a lot of people right now. So I know for folks tuning in, that may be frustrating for them. Maybe it's confusing. It is happening in conversation more and more. I think that is going to be helpful in the long term. Companies like Armstrong have tried to lead with products that have EPDs and HPDs on all of our products. And so that does tend to raise the quota when companies jump on board to do that, and competitors see themselves losing projects because they don't have those things, raises that standard. And we're seeing that more and more as we move into projects, which I think is important. And on the concrete thing, it's actually interesting when I tie back to what I was mentioning earlier about this phase change material is a classification of thermal mass, right? It's actually doing the same thing as what concrete is doing, not structurally, but in terms of absorbing heat, the way that concrete does, or the way that water does. We use water in our hot water tanks because it's a good storer of thermal energy. Well, phase change material in a ceiling is doing a very similar thing. And there's this sort of interesting thing going on where we're removing concrete out of buildings to decarbonize buildings, but at the same time, we're also making our buildings lighter and lighter weight in terms of the way we used to control temperature in buildings in ancient and older buildings was with thermal mass. We didn't have insulation until the early 1900s. So as that comes online, we go more global sourcing of materials, and having locally sourced materials becomes much less prevalent. And so we manage our comfort using insulation, but stripping thermal mass out of the equation is kind of like taking the ice out of the cooler. It's like you're just purely relying on refrigeration and having a good cooler. And so having thermal mass is sort of an important element that's a bit of a challenge as we walk into today's buildings, where there's way more glazing, way more sort of metal and composite materials, lightweight materials that don't hold heat or thermal buildup very well as a resistor to that. So this idea of using phase change material in ceilings is an ability to sort of retrofit back in or introduce thermal mass back into buildings, knowing that we're sort of motivated to strip that out on the embodied carbon side wherever we can. So something worth mentioning as it relates to that sort of trend that we're also seeing in the decarbonization of materials. So.
Okay, kind of moving to a different angle on it. So nothing happens without, people, time, and money, right? And with the emphasis on the money piece. So what are the key trends that have emerged in healthy building investments, and how are they influencing the business case for decarbonization and healthy buildings? And how does that influence leasing decisions? Joe, you want to start off with that?
Yeah, so these are really quite big changes out there, and we can just talk it from a purely business perspective. So I wrote a book called Healthy Buildings with a professor at Harvard Business School. And in that book, we look at a lot of different things. And one of the things we do is look at the pure business case for high performing buildings. And even some of my work looking at the impact of air quality on cognitive function, we estimate the benefits to workers on the order of $6,000 to $7,000 per person per year at a cost of about $40 per person per year in terms of the cost benefit analysis. In our book, we rolled this up and looked at typical companies and what that might mean. And we estimate it could mean 9 to 11% gains in bottom line performance. Colleagues down the road at MIT did a study looking at these buildings that pursue these healthy and green certified buildings. They find they command higher rents. Lawrence Berkeley National Lab looked at the macroeconomic impacts, and they estimate there's over $20 billion in benefits to the US economy if we pursue these better buildings. So I think the business case is really quite straightforward. Honestly, motivated a lot of action prior to the pandemic. And I think then it became pretty existential for some organizations about what do I have to do about my building to make sure I'm creating these healthy spaces to bring my employees back. My employees are concerned. And it went from like a nice to have, maybe this is good for productivity, to a must have. It's table stakes to just have a healthy building. At the same time, this is table stakes now is also a building that's energy efficient. And I think the key driver is you having bottom up, so your employees are demanding it clearly. I think there are good companies with good management that also know it's the right thing to do. It's good for business, but also the right thing to do for the company. And then you have these top-down pressures, and I see this very clearly from the investor side, where they're not touching assets that are not energy efficient, that are not healthy. In fact, I do. This is new. I join due diligence teams looking at potential investments, and I add a healthy buildings lens because the investor wants to know, is this an asset that's going to retain its value, knowing that tenants are demanding places that are both healthy and green and energy efficient? So all of these market signals, just the pure business case, it's a no-brainer to do this. You say, and on the climate side, you're saving energy. The employees are demanding this. Tenants are demanding this. Take the GSA, General Service Administration. Their new requirements around healthy buildings, they are rewriting, renegotiating lease terms to demand not check the box indoor air quality and check the box energy, but really aggressive decarbonization plans, real-time indoor quality monitoring, water testing, air testing. So the signals are all out there that the good tenants are saying, hey, no longer is it just, this is a nice looking place, we're going to go in here. No, you have to actually hit these demands because their employees are demanding. And on the top side, the investors are demanding it. They're future-proofing their asset. No investor is going to come in here into one of these buildings, put a big bet down on a place that's not healthy and not green, not energy efficient. It's a foolish investment. And investors, of course, are not foolish. So you're seeing pressures from every angle, and this is why you're seeing really rapid market transformation, in my opinion. Plus, you have a tenants or buyers market right now, particularly in commercial real estate. So all of those are driving this rapid change in the department and moving it across all sectors and moving it from this, maybe we'll try this, is nice, to if you don't do it, your assets are going to be in trouble.
Yeah, Mick, anything to add there?
Yeah, I think something that comes to mind is a meeting I had here in New York a few months ago, and it was actually regarding lease rates and energy. And you've got buildings that may be fetching $150 to $200 or more a square foot in terms of the revenue that's getting generated per year on a building. And at the same time, you've maybe got that building that's consuming $10 a square foot in terms of energy. So there's an outsizable benefit in some of these buildings in terms of like the value of income coming from leases and tenants. And so the value of a hot and cold complaint, for example, or the value of a dissatisfied occupant becomes sort of awareingly more and more valuable sometimes than even when we think about energy alone. Like, what is the value of reducing those complaints? As Joe was saying earlier, human beings are pretty good at sensing challenges. As more sensor equipment comes online, that sort of gives more awareness. But obviously, there's a cost to addressing some of those concerns and problems. If you're getting 2 to 3 hot or cold complaints or issues within buildings a month, that costs money to address that. And we sort of like leave that to the side a lot of the time in terms of like, well, there's no value in that, but there's a real value on the P&L for that. But in addition to that, when we think about some of those, the value of your building, if you're losing tenants because of health and indoor air quality and hot and cold complaints, it adds up pretty quickly. So,
yeah, I see we're kind of getting up to about 10 minutes or so. I'm going to skip over one of our questions to get to the two final ones that I think are important. So one is that how do things like phase change materials contribute to both decarbonization and a healthy built environment? And is this a viable solution across what you might consider different, commercial buildings or industry types? Nick, why don't you start with that one?
So I guess there's sort of interesting overlap with it. It's I guess you could say a fortunate benefit. But when we talked earlier about the ceilings with phase change material in them, you've got something that wants to melt at 72 degrees. So you're incentivized in the summertime, for example, to pre-cool your space And ideally, you're doing that with ventilation. So you're in a climate that's cooler overnight, and you can drop the temperature. Even if you're using your chillers to do that, it's cheaper power, and you've got excess capacity in the grid at the same time as being the most efficient time of day to do cooling, dropping the building temperature. But ideally, if you're doing that with ventilation, you're helping improve air circulation within the building before occupants come in and setting the building up for the day. The phase change material in the ceiling is absorbing heat as temperatures rise. And so, sort of on the health side of things is obviously the airborne contaminant issues, which ventilation helps with. Reducing the peak temperatures of a building is also a really important factor in terms of buildings being comfortable to exist in and do our best work in. So whatever we can do to help support that is obviously an important element. There's just this interesting sort of overlap with ventilation where as we put these ceilings into buildings, we're also educating end users on how to better operate their buildings to improve or increase the amount of opportunity for ventilation to store free cooling early in the morning and leverage that later in the afternoon. It also sort of in some of those climates where we may have more natural disaster issues like power grid outages and maxed out grid due to maybe fires and things like that are going on. Things like phase change materials can be used in a capacity of helping support temperature during power outages as a resilience play as well. So something certainly that as we trend into areas that are more grid edge, cooling grid edge as well, that things like phase change materials can help hold temperatures in those climates, particularly when you think of desert climates and areas like that where there's nice dry diurnal swings. You've got this opportunity to just use ventilation to your advantage and store it to benefit later on. So this is an interesting sort of overlap and then sort of applies to a lot of different buildings. When you think of K through 12 learning environments, acoustics are really important, comfort's really important, energy efficiency, but so is health of the air quality and everything else that goes with it. Same with our healthcare, hospitals, and public gathering spaces as well. So these are all interesting overlaps. We see a lot of ceilings because we need a lot of acoustical control, but we also have a lot of gathering of people doing important work that need good air quality.
Thanks for that. Joe, anything to add? Has any of your work maybe gone into some of the other industry verticals, whether it's hospitality or manufacturing or places like that?
Yeah, for sure. I mean, the work we're doing is across all of these sectors. It's higher ed, it's schools, industry, healthcare, for sure. And I like what Mick was saying. I think, we've done some work. So this is more like at a societal level, but it's really important because it influences the individual buildings are going to influence what happens. But we wrote a paper and we wrote about in the Washington Post showing something that was called the Falcon Curve. It basically shows we try to electrify everything, which is good. We're going to shift peak demand to times of the year we never had to think about peak electrical demand. And currently the grid can't handle it. So it is the case, as Mick mentioned earlier, you could do everything you want to do, electrify your building, right? And you still could be drawing from a grid because our grid modernization isn't going to happen in the time scale that we need it to do. So the only way to actually get there is to also conserve energy and save energy. It's not just, hey, I can electrify and I'm all done, no on-site fossil fuel combustion, but you're also going to have to be drawing. And I think in terms of we're talking about like future-proofing of what's coming, this is clearly where it's going, where you're going to start to be penalized. We're talking about your carbon specific to time of day and the specific energy source that's being used as these peaker plants and others come online during peak demand, as more EVs come online, buildings electrify and the like. So the goal here of using any of these passive technologies, some of these active technologies to improve indoor air quality at the same time, kind of store the energy and reduce overall demand and reduce, honestly, the fluctuations that's happening in a building, which creates a lot of the uncomfort, creates a lot of the energy expenditure. And we could just be a lot smarter with how we're doing it. So I like the framing of it, just trying to tie it into these bigger conversations, what's happening at like regional scales in terms of our energy production, electricity production, and electrifying everything is not just the end all be all if you're not incorporating energy efficiency into that approach.
Right. We're seeing a lot of that in the Northeast right now, talking with both utilities, building designers, trying to electrify buildings using heat pumps. And there's concern that you get to this point where the grid just doesn't have the wires to support the heat pumps, let alone maybe the building infrastructure. So what else can be done to help reduce that load or manage some of those loads? But the interesting thing with some of the ceilings and the conversations we've been talking about is ceilings being able to absorb heat in the daytime, release it at night, helping smooth out, say, heat loads for early morning warm up and things like that. You could begin to imagine using buildings where you could preheat schools at 4 in the morning, even though it's cold outside, so that you can take schools off the grid early morning in January, so that everybody getting up to take showers using electricity for heating up their breakfast and things like that are able to meet those loads. So this sort of thermal energy storage and storage in general it's a lot of the reason we're hearing all of these ideas trending as we kind of figure out ways to support decarbonization in general of the grid.
Okay, we're kind of coming down to the wire here, so we have one final question. So maybe what we'll do is just ask you to, limit it to a specific recommendation. So with this, we're looking at, with this increasing demand for energy efficient electrified systems, what advice would you offer a facility manager struggling to meet their carbon reduction targets and indoor environmental quality standards? So I would think of it more in the near term. What can they do today versus what's maybe going to be coming, in the near to midterm future? So Joe, why don't you lead off with that one and give us
Sure. So let me say first, thanks for inviting me to participate. I think it's a great question. I've rattled off a couple, but maybe try to put it in a better framework here. So as you think about air quality, I think ventilation, filtration, absolutely important. Do not have to be energy hogs. And I mentioned earlier in the webinar things you can do: demand control ventilation, increase ventilation effectiveness, use of ERVs. I also think commissioning your building is a simple energy saving step that's going to help improve indoor air quality. But in terms of the larger framework, it's not just ventilation, filtration, and mechanical systems. We have to think about building the whole system, building envelope, surfaces, that's ceilings, walls, floors, and all of that, in addition to the mechanicals. And importantly, thinking about source controls. We had a whole discussion today on healthy materials. That's healthy materials that don't have toxic chemicals in it, don't off-gas as much, and also do right on their embodied carbon. We put all that together, we can actually improve indoor air quality at the same time, reduce our carbon footprint, and meet our climate goals. And I'll end with my last thought, tie into the where I opened these 5 fundamental shifts. We're not going back, right? These I've been talking about these as real fundamental shifts, right? The market is moving, and if you're not doing these, you're not first meeting your current demands, but you're also not future-proofing your asset for your current tenants, future tenants, prospective tenants, investors. And so you see all of the trends from the science to policy to new technology, public awareness. This is going in the direction it should be going. And it's actually a course correction from about 40 years ago, in my opinion, as I write about the history of this. So I think the strategies are totally attainable. Nothing here is asking for extreme measures. I don't think it's costly measures either. And I've seen it done in buildings, both the brand new shiny buildings, but also existing buildings that you don't necessarily think could possibly be a healthier, energy efficient building. We can do it in those too. So thanks for having me.
Vic, you want to have a closing thought there? We're not hearing you, Mick. Lost your audio.
Are you there?
Yep.
Did you lose me?
Yeah, you're on mute, I think.
Okay. So I would probably piggyback on the same thing and maybe start with retro commissioning, or really what that comes down to in my mind is like paying attention to what's actually going on. What can I turn off that's running that doesn't need to be running? And then, some of the sensors and things that we talked about earlier help us get a better idea of what's actually going on in our building, and then using the assets we already have to make incremental improvements on that when we can. Some of those would be major improvements when we find those big sort of opportunities. Others, like I said earlier, maybe using things like ceilings to improve air treatment, or adding thermal energy storage as you replace a ceiling tile because it's stained. One box at a time, you can be retrofitting these things into buildings. So these are important, but I think it starts with knowing the problems that you've got on your hands and starting to get to the bottom of some of that by just simple auditing and retro commissioning, and some sensor technology that has a better understanding of what's really going on for temperature and air quality.
Thank you. And as I've said in many of my discussions as well, is that, we've already picked all the low-hanging fruit. So now you have to get into some more complex solutions, like looking at your building envelope and maybe tightening that up, which may also reduce your mechanical demand, those types of things. So thank you both. This was a fascinating discussion. We could probably go on and on and on, but we're at time here. So I'm going to turn it back over to our hosts to close us out.